Hey, today we're going to learn something new core today. Here, would you like to read our standard for our class today?
Okay. Develop and use a model to describe the role of gravity and inertia in orbital motion of objects in our solar system.
Awesome. What are the keywords here?
The role of gravity and inertia.
Sure. And let's. What do you know about inertia and gravity?
Gravity is the force that keeps you on the Earth.
Okay. And what about inertia?
I think it's the force that keeps the water in the bucket if you spin it.
Oh, cool. Let's watch a video. And now I'm gonna show you a video. Now there's a sun in this case and the planets. So based on what you see in this model right now, I want you to write down your observations and your questions. Well, we have another student here today in the class. Awesome.
That was on video?
Okay. So based on the observation, what do you write down? Could you share with us?
Sure. It says, I wrote down here, everything circles the sun.
Mm-hmm.
But not in a circle. It's more of a squished circle.
Uh-huh.
And sometimes the planet gets much closer to the sun.
Uh-huh.
The ones closer goes round more times, and some move faster than others.
Okay. Now, did you get a chance to draw a model about how it works? Why the planet orbit around the sun?
I know. No.
Yeah. It's right here.
Uh-huh.
So there's the sun,
Uh-huh.
and then you got the planet,
Uh-huh.
and the direction of the rotation.
Okay. Does it explain why it rotates around the sun? Revolve around the sun. You did not say?
I don't think so.
Okay. Okay, let's do some experiment. So, do you think that there's any problems with the model you see in the picture? What do you disagree with?
It's not to the size.
Not the size, okay.
I'm sure it's.
Can you make a claim why the planets orbit around the sun? Like why? You think this is why it rotates orbit around the sun?
Based on the objective, I'm gonna guess gravity and inertia.
Oh, that's your claim?
Yeah.
So gravity inertia is the cause that why this planet orbit around sun. Sure, that's your claim. Awesome. Let's do some experiment. We're gonna find some more information to support your claim. In this case, let's do the first one. So you get a piece of paper, and you get a snowman, and can you be my students, Louis or Renjie? Who can be my student?
Me.
Okay, Louis raised the hand. Thank you for raising hand so quietly. Here, Louis, come here. So we're gonna have a snowman right here, right here in this case, and I want you to yank this paper as fast as you can and see what happened to the snowman. Okay, what happened?
It stays there.
Stay there. Why do you think the snowman stays there?
Because when it's going like that, it goes like that.
Okay. What about if you yank it very slow? What happens?
It'll
Stay,
take the
huh?
Pokemon. It'll take it with it.
Come on.
Okay. And what if you yank it very fast? Why do you think it stays?
Because maybe it's too like quick, so it's like gravity help with this too.
Oh.
Because like gravity's on this, so but if it's going like that, it doesn't fall off.
Okay, Jamie. Thank you, Ren. Thank you, Louis. Thank you for explaining. So, Jamie, in this case, can you use what Louis demonstrated to explain?
do it, Dad.
To explain.
Dad, I'm gonna do it.
Can you use the idea of gravity to revise your model?
Okay.
If so, what part of your model would you like to change?
I think that I want to draw some arrows showing that gravity is pulling the planet toward the sun.
Draw some arrows.
Yeah.
So let's have you draw arrows here. Draw arrows. You want to draw arrows? Sure.
So the gravity is the force pulling it toward the sun.
Oh, nice.
Somebody play that place, maybe.
Okay, let's do another second experiment. I'm gonna give you a pen, a lid, and there's a circle, and there's a ball here. I want you to go at slow, and then go fast, and see what happens to the ball.
Okay, Andy. Oh, no.
Oh, so what happened when you go fast?
It came out.
It came out. Okay, could you write down your observations?
All right. Okay.
Okay, you. Mom, I was gonna sit there with Bible.
Okay.
And actually, guess what? The milk might already spill on you. The milk might spill on you, Mommy, if you don't move.
All right. Let's see how the gravity will make the milk go in your bowl. Yep. All right. I wrote it down.
Okay, awesome. So what part did you change?
So I said moving. If it moves faster, it flies out. So the arrow showing inertia is a force that's pushing it away from the sun, but only when it's moving. And if it goes too fast, it will pull away from the gravitational force and fly out.
Okay. What you said? Say that one more time. You said why it flies out?
Because if it's going too fast.
If it goes too fast and it flies out.
Yeah.
So, what's another word for being fast?
Acceleration.
Acceleration is the movement. Going too fast means I don't know. What's the word for it?
So we say this object has a great
Speed.
Oh, speed, huh? Speed is another word, huh? We can use.
Oh.
Okay, so when it has a great speed or velocity in this case, and then so you flies out. That's that's your conclusion. Good thinking, huh? Good thinking. Any objections? Any things that you think we didn't clarify? Now I want you to take some time to do your own. Do you have an investigation you want to try? To help you to draw a better model in this case.
Well, does like a bigger planet versus a smaller planet
Okay.
would be you'd have to go faster
Okay.
depending on what the gravitational pull is, right? So like I observed earlier that some of the planets could go faster. So maybe just add it doesn't looking into why the gravitational pull versus the inertia would determine the sweet spot that they could move, right?
Okay.
You watch a Bible.
Cool. Cool. So would you like to take time to write your plan for your investigation, or do we want to write it for some vocab teaching?
Vocab teaching.
You want to do vocab teaching?
Yeah.
So write down the definition of the gravity then.
Okay.
What do you think the definition of gravity is, and the definition of inertia?
Gravity. And then inertia.
That's okay. You don't.
Dad. No anymore. Another pair of Rice Krispies.
Why not?
Because it'll run out fast.
Exactly.
Okay.
Okay. So, let's see. Can you read to the class? The
Okay.
gravity means what?
The force pulling objects toward another object.
Okay. Inertia means.
The force that directs objects in motion away from another object.
Interesting. Interesting. I like your definition. Let's how about this time? Let's Google it.
Okay.
Let's Google find out the definition of gravity.
Gravity.
So gravity, based on the Google, the force that attracts the one a body towards the center of the Earth or toward any other physical body having mass. So that's first one is very close, huh? Let's do the second one. Second one is that is inertia. Okay, let's read.
Inertia.
A tendency to do nothing or to remain unchanged.
What?
Let's read again. A tendency to do nothing or to remain unchanged. How do you use that information to change your
Mom, look at the top.
I don't know. I don't get it.
So that means if no force is applied on it, so let's come back to the snowman. Let's come back to the snowman. So when you pull the paper, yank the paper, and why does when you yank so fast, what does the snowman do?
Because gravity is pulling down on it.
Okay. Before you pull it, did the snowman move?
No.
It stayed on the paper, yes.
Yeah.
It's motionless.
Yeah.
But when you pull the when you pull the paper very fast, it didn't move with paper. It stayed where it is. So you can see, you can understand in this case, that's the inertia. It's motionless.
Okay.
Because the definition is a tendency to do nothing or remain unchanged.
Huh.
This is
So now, I
basically-
want you to use
the
that.
paper is basically gravity.
Thank you. So now I need you to use that demonstration to explain, revise your definition for inertia here. Okay, awesome. I think you have a better understanding right now for the key words For sure. Now I want to discuss with your group, and then I want to communicate your prediction. What do you think happened, or what your patterns? Like I want you to create a model. I want to create a model. So today we're gonna use a budget paper. And you're gonna cut out the sun and one planet you choose.
Okay.
And then I want you to use the sun and the planet to explain why the planet orbit around the sun.
Okay.
That's our part. Thank you. That's a class.